So I am starting section 2.3 about midway through what I have written up because I spent a decent amount of time writing up theory that will tell us why the rule that we're going to use today works, but the theory doesn't really help you use the rule, and I think it's just a little bit too much. The rule is kind of tricky enough to apply. To dump on theory that you don't really need didn't feel really useful. Today, we're going to learn something called the chain rule. And the chain rule is used to find the derivative when you have a parentheses with an exponent and we don't want to clear that exponent. Then it's a candidate to use this chain rule. Better yet, maybe I can say I have some number without a letter times a parentheses with an exponent. And when that's the situation, if I have a number times a parentheses that has an exponent outside of it, and it's either clunky to clear the parentheses or I can't clear the parentheses, then the chain rule is going to be the rule that we apply. And I've written symbolically and in words what the problem looks like. Then I wrote symbolically and then in words what the derivative looks like. This might be a little fonted small because it was so long to write this rule in words that I had to font it down to 12 point as opposed to 16 point. That is a little easier when I'm, lecturing. So the chain rule basically says if I have a number without a letter times a function raised to the n power, usually in a parentheses, then the derivative is the exponent times the coefficient times the derivative of what's inside the parentheses times the original parentheses unchanged with the exponent lowered by 1. So if you have a number without a letter times a parentheses to an exponent, its derivative is the exponent times the coefficient times the derivative of what's ever inside the parentheses times the original parentheses with the exponent lowered by 1. Let me show you what I mean by doing an example. So let me just maybe word this out rather than symbol this out. So if I look at this problem, I have a number times the inside of a parentheses with an exponent. How do I find the derivative? To find the derivative, I take the exponent, in this case 4, multiply it by the coefficient 5, and then I have to multiply it by the derivative with the inside of the parentheses. The proper way to write that is I'm multiplying it by the derivative of 3x plus 8. And the derivative of 3x plus 8 is what I'm going to write right next to it. So it's the exponent 4 times the coefficient 5 times the derivative of what's inside the parentheses. This is a symbolic way to represent I'm going to find the derivative of what's inside the parentheses. Inside the parentheses is 3x plus 8. The derivative of the 3x, because it's a first power term, is 3. The derivative of the 8 is 0. So there's my exponent, coefficient, times the derivative of the inside the parentheses, times the original parentheses with the exponent lowered by 1. So I'm going to take the original parentheses and lower the exponent by 1. And now I'm going to write my derivative after I simplify this. I'm going to go 4 times 5 is 20, times 3 is 60. The derivative using the chain rule is 60 times 3x plus 8 to the third power. In the beginning of the video, well, if I was going to lecture at the beginning of the section, I'd probably explain better how this rule works and why it works, but that's probably not the best use of our time. Let's do another one of these and use the chain rule to find this derivative. So in this particular case, there's no number there. I don't know what the heck's going on there. Let's do the chain rule. So the chain rule says if I have a problem written in the form a coefficient that doesn't have a variable times a parentheses with an exponent, and that's exactly what I have here, but the coefficient was an implied 1. How do I find the derivative? I find the derivative by bringing the exponent down, multiplying it by the coefficient, and then by this, I have to multiply by the derivative of the inside of the parentheses. I need to take the derivative of 3x squared minus 7x plus 5 and write it right after the 2 times 1. In the last problem when I did this, I didn't include a parentheses because the derivative was just a single term. Here, when I write the derivative of what's inside the parentheses, that's what I'm writing next, I need to use a parentheses because this is going to be a binomial. So the derivative of 3x squared is going to be 6x. The derivative of minus 7x is going to be minus 7, and the derivative of 5 is going to be 0. So the derivative of the inside of the parentheses is 6x minus 7. So this is part of it. The exponent times the coefficient times the derivative of the inside of the parentheses times the original parentheses with the exponent lowered by 1. The original parentheses with the exponent lowered by 1 is going to be 3x squared minus 7x plus 5 to the first power. Let me just clean this up and call this the derivative. I'm going to multiply the 2 and the 1 and get a 2. Didn't really even need to write that 1. It's not necessary. If there's not a coefficient, I can still use the chain rule. There's an implied coefficient of 1. And it's better to leave the problem factored than not. I can suppress that exponent of 1. And I'm not going to multiply these out. It's actually better to leave them factored. So we can kick it up a notch, and this is the hard part of this section. What happens when you need 2 rules? This is the first time we're going to have to delve into using multiple rules. When I look at this problem that I'm flashing up on the screen right now, it's not a perfect candidate for the chain rule. To use the chain rule, the number in front of the parentheses is not allowed to have an x. Once the number in front of the parentheses has an x, I can't only just use the chain rule. I actually have to use both the product and the chain rule. Here, I have multiplication and both factors have an x, so I need to use the product rule. And in the middle of doing the product rule, I need the chain rule. This is awful. So first, I'm going to set up the product rule. The reason I need to set up the product rule is because there's multiplication, there's a first factor and a second factor, and both the factors have an x. I can't use the chain rule directly when the coefficient has an x. So what do I do for the product rule? I write my first factor, which is 2x, and I write its derivative down. Its derivative is baby. The derivative of 2x is just 2. And then I write the second factor. This is where bad things happen. The second factor is 2x plus 3 squared cubed. 2x plus 1 cubed. And now I need to write its derivative down. This is where the chain rule is coming into place. Now I have something that's permissible for the chain rule. Let me do this derivative down here. This problem is really 1 times 2x plus 1 cubed. This derivative that I'm about to do, I can use the chain rule because the coefficient doesn't have a letter. So what do I do to do the chain rule? I take the exponent 3, I multiply by the coefficient 1, then I multiply by the derivative of the inside of the parentheses. And that's the symbolic way to say I'm finding the derivative of the inside of the parentheses. The derivative of 2x is 2. The derivative of 1 is 0. I don't need a parentheses when I'm tacking on the derivative of the inside of the parentheses because it's just a single term. And then I lower the exponent by 1 and leave the parentheses unchanged. So this derivative, I needed the chain rule, but I couldn't use the chain rule right from the start because the x in front of the parentheses with the exponent doesn't permit the chain rule. The chain rule, the number in front of the parentheses can't have a variable. So the derivative of this is 3 times 1 times 2, which is 6, times 2x plus 1 squared. When I use the chain rule and the product rule together, I always factor because there's a really common factor that was going to pull out every time. So now, product rule, I cross multiply down, first factor times derivative of the second, cross multiply up, second factor times the derivative of the first, and put a plus sign between. So my derivative, I'm just going to write y prime, just because it's easier, is first factor times derivative of the second. That's 2x times 6 times 2x plus 1 squared. And then plus from the formula, second factor times derivative of the first, written in a nice order, 2 times 2x plus 1 cubed. And let me slowly factor out this common factors, which is very customary and necessary when you do these. First of all, on either side of the plus sign, I see a 2. I'm going to factor out a 2. That's the easy common factor. I'm going to write a 2 followed by a parentheses. And then what's left here is x times 6 times 2x plus 1 squared. I'm going to write that as 6 times x times 2x plus 1 squared. After the plus sign, I have a 2x plus 1 cubed. Now the ugly common factor. On either side of this plus sign, each has a parentheses with a 2x plus 1. I take the smaller of the exponents and make that my common factor with the parentheses. So I'm going to get a common factor of 2x plus 1 quantity squared, which is the common parentheses with the lower exponent. When I take the 2x plus 1 squared and factor it out from the first piece, it's gone completely. I'm left over with the 6x. After the plus sign, I had 3 of the 2x plus 1s. I factor out 2, so I'm just left with 1 of those 2x plus 1s. Now I'm almost done. I just need to clean up this parentheses. So the derivative is 2 times 2x plus 1 squared. And then inside the parentheses, that 2x plus 1 doesn't need to be written in a parentheses. It has an exponent of 1. It doesn't have a coefficient. I can just drop the parentheses and then combine my like terms. My derivative, fully simplified, is 2 times 2x plus 1 squared times 8x plus 1. That's on steroids, my derivative, but it's correct. As near as I can tell, it's correct. I think I've got a math error somewhere going on, but I should, what's going on here? Something's happening in my life that's not good. I don't even see the problem anymore. Oh, I do have a horrible mistake. Do I want to fix it? Not really. When I wrote down the first factor, it's not even the right first factor. The first factor, I should have written 8x here. I wrote 2x maybe because I want to make my life easier. Let me pretend that I found a correct derivative, but I made a bad mistake on the first step. I found the derivative of 2x times 2x plus 1 cubed. I did it perfectly, but I didn't really find the derivative of the problem I was asked to find the derivative of. My debate is to fix my mistake, to change this 2x to an 8x, to make its derivative 8, and then go through all the steps again, or pretend that this was the problem and call my work correct. So my work is correct for the derivative of this. My work is incorrect for the derivative of this because I should have wrote 8x here and 8 here, and then every place I had the 2x, it should be an 8x. Every place I have this 2, it should be an 8. All my work, although it's correct, it's not correct for the right problem. I don't feel like redoing that, and we'll get lots of practice at this. So let us not fix that and call that the derivative, and of not the problem that was the example. I found the derivative of not the example problem. I correctly found the derivative of 2x times 2x plus 1 quantity cubed. I did the first factor, new first factor that I made up myself. You're not allowed to do that, but I guess I am, sorry. And the second factor, its derivative, its derivative, cross multiply and plus, and just deal with that horrible error. I'll try to compensate for that error when we get deeper into the section. We'll do more problems like this. I don't know why I did that, but it is what it is. So the next big skill we need is to finding equations of tangent lines. And we've done tangent lines given values of x's and tangent lines that are horizontal. This is a tangent line that's horizontal. We've done this twice, I think, maybe once. So how do I find all values of x where the tangent line is horizontal? To do part A in this example, we need to find the derivative and set it equal to 0. Because tangent lines are horizontal when the derivative is 0. And to find the value of x that make the derivative 0, you find the derivative and set the derivative equal to 0. So let me do part A. So I need to find the derivative. So this function is f of x equals 5 times 3x plus 8 to the 4th. That's the function I want to find the derivative of. Perfect application of just the chain rule. That's multiplication of a constant times a parentheses to the exponent. So the derivative is going to be found by taking the exponent 4 times the coefficient 5 times the derivative of what's inside the parentheses. What's inside the parentheses is 3x plus 8. The derivative of 3x is just 3. The derivative of 8 is just 0. So the derivative of what's inside the parentheses is just 3. That's the hard part of the chain rule. Exponent times coefficient times the derivative of the contents of the parentheses times the parentheses with the exponent lowered by 1. So my derivative is going to be 4 times 5 times 3 is 60 times 3x plus 8 quantity cubed. That's the derivative. To find the values of x where the tangent line is horizontal, I take the derivative and set it equal to 0. So I'm going to go 60 times 3x plus 8 cubed equals to 0. Since this is factored, I can just split each factor up, set 60 equal to 0, and set 3x plus 8 cubed equal to 0. The 60 equal to 0 doesn't give a solution because there's no x to balance out. When we have a parentheses with an exponent equal to 0, the most efficient way to get the answer for x is just to set the inside of the parentheses equal to 0. I could cube root both sides, but that's getting to be almost too much work. The answer to part A, the value of x of negative 8/3 is the value that if I plug it into the derivative, I'll get 0, which is the slope of the tangent line. Let me just show you. If I take negative 8/3 and put it into the derivative and go 60 times, parentheses, 3 times negative 8/3 plus 8 quantity cubed. If I plug this answer into the derivative, I get 0. Plugging a number into the derivative gives me a slope of a tangent line. I plug negative 8/3 into the derivative, I got 0, which means the slope of the tangent line when x is negative 8/3 is 0, and horizontal lines have slopes of 0. So my answer to part A is just this. Anytime I'm not given a value of x and I'm asked to find a value of x where tangent lines are horizontal, you simply find the derivative, set the derivative equal to 0, and solve for x. For part B, I'm going to find the equation of the tangent line when x is negative 8/3. And because I'm finding the equation of a horizontal line, my answer to part B will only have a y. It's going to be y equal to some number. And if I'm clever, I can minimize my work, but if I'm not clever, not such a big deal. So far, in part A, it told me I'm finding the equation of a horizontal line, and I have to know that horizontal lines have a slope of 0. In part A, I found the x-coordinate of the point, which is negative 8/3. Anytime I find an equation for a line, I need both an x and a y. I'm going to get the y-coordinate by going to the original function. Now I'm going to change the x in the original function to negative 8/3. I'm going to try to do this on my calculator. If I had my newer calculator, it works better, but it doesn't show up on my DocCam. So I'm going to go 3 times negative 8 divided by 3 plus 8, up arrow 4. So I did 5, the coefficient, times 3, and put negative 8/3 in for x. So 3 times negative 8/3 plus 8 to the 4th power. Oh, and I get y equal to 0. So the y-coordinate of my point is 0. That's just a fluke. And now I'm going to find my equation. I'm going to go y minus the y-coordinate of the point equals the slope times x minus the x-coordinate of the point. On the right-hand side, it doesn't matter what I do. 0 times anything is going to be 0, so the right-hand side is going to be 0. The left-hand side, y minus 0, is just y. My answer to part B is y equal to 0. Now we're ready to do some homework. And we're skipping the part that is the theory. There's a lot of theory homework problems. So when we actually do our homework, we're going to start at problem 17. So we're going to skip on and we're going to start our homework at 17. And I had to fix up this rule, and this rule's not quite right there. Let me pause and do a part 2, fix this rule up so I don't have to cross it out and write it correctly every time.